Let's start with 23, since that's kind of numerically the beginning. So y'all should have your books open and all that good stuff, right? 23, that's the 3 kilogram ball dropped from the roof of a building. Does that sound right? 176.4 meters high. While the ball is falling towards the earth, a horizontal wind exerts a constant force of 12 newtons on the ball. How long does it take to hit the ground? So this is really a projectile motion question. It's a projectile motion question. Do you remember when we were talking about projectile motion, the very first day we had that one ball bearing that fell straight down? We had the one that went like this, and then we set up our chart. Does this sound familiar? And we said that the acceleration due to gravity was always going to be negative 9.81 meters per second squared. And we said that the acceleration due in the x direction was always going to be, except that I said only about 99.7% of the time. This would be like the 0.3% of the time that it's not. So the deal is with this one that, so here's your building and here's the object. So it actually is going to feel a force from the wind in that direction. And it's going to feel a force of gravity in that direction. Which means that it's going to accelerate both in the y direction and what? Exactly. So that means that when you set up your chart, you have dx, vx, ax, dy, vy, ay, and then you have t, right? Ax is going to be not 0. What's it going to be? Any ideas? How would I find that? Matt's got an idea. What you got?
Well, seeing as the force is 12 newtons, seeing as we know that that's mass times acceleration,
Okay.
then we could do the force divided by the mass.
Yeah. So the force of the wind is 12 newtons, and that's the net force in the x direction, right? There's no other force in the x direction. So that's going to equal the mass times the acceleration in the x direction. The mass is 3, so that means the acceleration is, without a calculator even, it is, yeah. Does that make sense? Okay. So that's the little bit of funny part. But that actually only matters in part B. Part A you can do just with the y stuff, just like we did in chapter 3. Does that make sense to you guys? Just like it's just not going to leave you. You're just going to have to keep doing it. And don't worry about part C. I'm just going to say that. Is that fair? Okay. So does that answer your question?
Yeah.
Okay. Any other questions on number 23? Is that all right? Okay. You guys are like super quiet today. 28A, let's take a look. It says draw a free body diagram showing the weight and normal force. So weight means what? It's close. It's not the mass. It's a certain force. Which force is it? Force due to gravity. Okay. So if you see the word weight, you can just automatically every time transfer that into F sub g. So they want to know where the weight is in the normal force on a laundry basket in each of the following situations. So, Skylar, was this the one that you were asking about?
Yeah, I just want to make sure I did it
okay. So in A, let me scroll down a little bit here. So 28A is just, it says it's on a horizontal surface. So here's my laundry basket. This is really just like the frog, except without eyes, right? Yeah. So you've just got gravity pulling down. And if we were a really good kid, we'd actually write that's the force of the earth on the basket, Fg. And then you've got the force of the surface on the basket, Fn. Does that make sense to you? And that's all you have to do. Yeah. Now, on B, C, and D, what's different on B, C, and D?
Oh, they have angle.
Yeah. So those are going to look more like the force of friction lab problems that we did. So you would have your normal force going perpendicular to the surface, gravity pulls straight down, and then friction goes up the ramp. Does that help? Okay. Mhm.
So it's 23B. The
Yep.
BX is 0, right?
Yes. Yes. Okay. So we're done with that one. We're done with that one. 53. Is this the one with the little kid on the sled? Yes! Sorry, I was excited because I like this question. How many of you think you got this one? Yeah? Anybody? Yeah! A couple hands. Sweet. Let's do it. I think this one's so much fun. This one's like a big, chunky problem, right? There's a lot going on in this question. But it's good. It's a good question. All right. So everybody with me? So if your hand did not go up a minute ago, and that was many of you, write it down now. Here we go. We're going to do it. Mustafa, did I see the question or?
No.
Okay. All right. A girl coasts down a hill on a sled, reaching level ground at the bottom with a speed of 7 meters per second. The coefficient of kinetic friction between the sled's runners and the hard icy snow is 0.05. And the girl and the sled weigh. So what does that mean? If they weigh, that's the force of gravity. Is that okay with everybody? Okay. 645 newtons. How far does the sled travel on the level ground before coming to rest? This is such a fun problem. Okay. So really we don't care about the hill at all. We just care about when she gets here. So here she is, and she's moving with an initial velocity of 7 meters per second. At some point, after traveling some distance, let's call it D, she's going to be here with a velocity of what? 0. Does that make sense? Okay. So I'm just going to kind of work backwards to figure out what I need to do. I know the initial velocity, I know the final velocity, I know the displacement, but how many things do I need in order to use one of those nice kinematics equations?
4.
I need 4 things. I got 3. Any idea what other one we might be able to find that would be helpful? We could find time, although in order to find time, we would still have to know something else, right? Yeah, because our D is a question mark, so we don't actually know what that is. Thinking about what's in chapter 4 and all of the discussion in chapter 4, ideas? Acceleration. I'm thinking that might not be a bad deal. Because if we look at some like intermediate place, she's moving. What forces are acting on her while she's moving? I'm going to just draw it. Hold on. Gravity, or the force of the Earth on the sled, Fg. And we know that value, right? It told us. What other forces are acting on her? Raise your hand if you can tell me another one. Go, Cade. Friction. Which way is friction going? The opposite way that she's moving, right? So she's moving to the right, then the force of friction is going to go to the left. Oops, and I should actually write the force of the surface on the sled, FF. Cool. Are there any other forces acting on her? What you got? Normal force. How do I label that one?
Surface on.
Yeah. Okay. How do these, let me ask a question before. Are there any other forces? No? How do these two forces compare? How does Fn compare to Fg? They're equal. How do you know? She's not accelerating up and down, right? So that means that you can find Fn pretty easily, right? Because you're no Fg. Is that true? Yeah? Okay. What is the net force in the x direction? Is there any net force in the x direction? Is she accelerating in the x direction? Yeah. How do you know she's accelerating in the x direction? So what was it?
She's changing the velocity.
Yeah, her velocity's changing, right? Velocity changing over time must mean acceleration. So if we wrote this out, we could say that the net force in the y direction is ma in the y direction is equal to Fn. I'm just kind of putting this all in paper now, or on here now. Okay. You said that this was 0. So that means that the normal force equals the opposite of the force of gravity. Is that okay? And we can say that F net in the x direction is equal to max. Do I know what the acceleration in the x direction is? I don't. That's what I'm trying to find to do that other stuff. But I can find it because what forces are acting in the x direction? Friction. Anything else? No. Okay. Do I know the mass of her? Yeah? What is it?
It's 645 newtons divided by its.
So you don't really know it, but you can find it, right? Okay. So I can find this. That's going to be Fg divided by little g. Is that okay? I'm not going to go through the whole problem, but I just want to make sure it's making sense to you. Okay. Can I find Ff? Is there a way to find the value of Ff? Yeah, it tells you the coefficient. Yeah. So we can say that Ff is equal to mu times, what was it? Fn? And we can find Fn from there. Is this making more sense now? Okay. So if I was going to kind of put a list of things to do, I would find the mass. I would find the normal force. I would find the force of friction. And then that would lead me to find the acceleration. Are we okay there? And then I would take that acceleration and say, oh, but I know the initial and final velocity. I know the acceleration. I can find the distance, right? Really quickly, just so that we're all on the same page and you feel good about this when you go home, look at your equation sheet and find the equation that you'll use. If you have initial velocity, final velocity, displacement, and you just found your acceleration, which equation will you use? Think you found it?
Yeah.
What is it?
E plus m pi t plus 1 over 2at squared.
What'd you say? This one?
Yeah. No.
Is that
Okay.
the choice that, where you're changing your story?
To yes, I'm changing my story.
Can you tell me why you're changing your story?
Because there's no refined there.
Right. Correct. There's no V final in that one, and there is
I
a...
don't have a good time.
Right, exactly. So let's get rid of that choice.
I just love this. So.
I know! It kind of breaks your heart when you don't get to use that one, doesn't it? I hear ya. I hear ya.
May I tell it now?
Please.
V final square is equal to
Uh-huh.
V initial square plus 2at.
What do you guys think? Does that seem like a better choice? Yeah. Nice job. What's
Can
up?
you scroll down now?
Sure, of course. Like that far, or do you need to go further?
Yeah, so
I guess that is the part. Does that get you where you need to go? He was like, yeah, sure. But I got it. So cool. We doing okay? Is there anybody that feels like you need a little more push? Because I can give you more of a push. I just don't want to tell you too much because that leaves the fun out for you. Yeah.
also to find FF instead of actually finding the mass, since it gives us mu and then we can find FN. We can do that again. Or wait, later.
You need to do it both ways.
Yeah,
Yes.
you still need to find mass.
Yes. Yes. Yeah. All right. Are we good? Excellent. Excellent.